In this session, let's talk about this reference when it comes to arrow functions, how this keyword works. In one of the previous sessions, we already saw how this reference works for normal functions. Let's quickly revise that concept. For a normal function, this always refers to the object that is running the function. So in this particular case, we have car object, we have some properties in that object, and we have a function which is a normal function and which is using this keyword to refer to the properties of this particular object. So when we do car dot display car, what are we doing? We are calling this function with this particular object. So car is calling the particular function. So this reference from this function will refer to car object. So when we run this program, we can see Toyota Land Cruiser. In other words, this keyword, by using this keyword, we are able to refer the properties of this particular car because we are using that particular object to call this function. So in short, for a normal function, this keyword refers to the object that is currently calling the function. Now this concept is completely opposite when it comes to arrow functions. We'll go to arrow functions in a bit, but let's modify this particular object a little bit. Just to go into that particular context, let's modify it a little bit. Let's say in this function display car, we want to create another function. So we are doing like nested function here. So what I'm saying is, as part of this function, I have another function. Let's call it as display make and model, and this console.log, let me put it here. And also we have another function, let's say display price, and what this is doing is display price is simply displaying the price of the car. Okay, so at the end, let's also call display make and model and display price. Okay, this may not be a very valid use case, but just for understanding the concept, let's say we have a function inside an object, and as part of that function we have two other functions. Car object is calling display car function, and when display car gets executed, as a consequence, these two functions are getting called. But note that car is not calling them directly. Like car is calling display car function directly. Display make and model and display price, these two functions are not called by car object. So by definition, this reference for these two functions should not point to car object, and ideally we should not be able to access the parameters or properties of the car object because this is not pointing to car object itself. Then let's see what happens and run the code, and we can see that inside these nested functions, when we are making this dot make, this dot model and price, we are not able to access these parameters because this is now pointing to the object which is running this function. Who is running this function? Which object? Car is running display car function, and as a consequence these two functions are getting executed. So in this case, when car is not running them, they are actually run by the global object. So by default, this reference points to the global object. In the global object, do we have make, model, price? Are they defined at the global scope? No. That is the reason we are getting undefined, and this is a very common issue. In JavaScript, we face this kind of issue when we work with either nested functions or with callbacks. In such cases, when we have these kind of issues, arrow functions are very useful. So let's talk about arrow functions. By definition, they do not have this context. So arrow function do not have this context by their own, but what they do is they inherit the value for this from the surrounding scope. So this is completely opposite to the normal function. For normal function, it doesn't matter where the function is defined. This context will always refer to the object that is calling the normal function. But for arrow function, it doesn't matter who is calling them. This reference will always get inherited from the surrounding scope, from the parent. So in this case, who is the parent for these two normal functions? This is display car function. Then to whatever object this reference for display car will point, the same will be true for these two functions. So what I'm saying is, when we convert these two normal functions into arrow functions, this reference for them will be same as that of this reference for display car function, because display car is in a way parent for these functions. And for an arrow function, this reference is inherited from the surrounding lexical scope. Lexical in the sense as physical scope, where the function is defined. Whoever is the parent for that function, this reference for the parent is inherited as this reference for the arrow function.
Hey there! If you're finding this video helpful, you'll love our full online course on JavaScript with node.js. It goes even more in depth and covers everything you need to know. Check out the link in the description to enroll and take your skills to the next level.
So let's quickly convert them into arrow. So I'm going to use this as a variable name where we can assign this arrow function. So display make and model. And similarly for display price. Okay, so like this we can convert a normal function into arrow function. Now as soon as we convert them into arrow function, this reference is now pointing to the same this reference for the surrounding lexical scope, which is display car function in this case. And when we rerun this program, the output is Toyota Land Cruiser 60,000. It means now we are able to access the properties from car object without any issue, and this is possible because this reference for these functions is not now pointing to the same this reference that is there for the display car function. So two important things which we want to understand here is the difference in this reference for a normal function and for arrow function. For normal function, this always refers to the object that is currently running them. As simple as that. If some function is running standalone, in case of normal regular function, then this reference will by default point to the global object. Okay, that global object will be window for a browser, or for node.js, it will be global. Now, when it comes to an arrow function, this reference will always get inherited from the surrounding. So it matters where we are creating the arrow function. Where we are creating the arrow function, it will look for the surrounding. From its parent, it will inherit this reference. So for example, for parent, this reference is pointing to ABC object. Then for the arrow function, this reference will also point to that same ABC object. As simple as that. And that's how this definition goes. Arrow functions do not have their own this context. Instead, they inherit this value from enclosing lexical scope. Okay, now some of you might say, what if we change display card to arrow function? Will it work? Well, let's see what happens. Let me quickly copy it, and let's just remove these inner functions. Let's call this object as car2, and now what we'll do is this one, which is currently a normal function, let's change this into an arrow function. Okay, so what did we do? We just changed this one into arrow, and now by definition, arrow function does not have its own this context. It inherits this context from the enclosing lexical scope. So who is the parent for this function now? Car2 object. What is this reference for car2 object? It's definitely not car2, because object cannot point to itself, right? This reference for car2 object will be pointing to the scope where it is defined. Where is this object defined? It's in the global scope, right? The object currently is defined in the global scope. For example, if you simply do console.log and this here. So the value of this reference here will be similar to the value of this reference for the car2 object, because it is defined at the same level. Because the object is defined at the global scope, this for car will be pointing to global object, and in browser that object is window. In node.js that object currently will be an empty object. So if we quickly clear it and rerun, basically let's do it 2 here, and when we rerun, this one is coming from this. So this is pointing to an empty object because this is node.js. If this was a browser environment, then this will be pointing to a window, which is a global thing. Now let's come to arrow function. This reference for arrow function is now pointing to which object? Not car2, but the same empty object. Does this empty object have make and model properties? No, and that's the reason we are getting undefined. So for an arrow function, we have to be very careful where we use them. Okay, in such situation, if we use arrow function, it may not be very useful because this reference will again get inherited from the surrounding parent. If the parent is and definitely not pointing to itself, it is now pointing to a global object, in this case an empty object, and that empty object does not have these properties which we are trying to access, and we are getting undefined issue. Okay, why did we see this example is to just understand how this reference work in case of arrow functions. For an arrow function, it does not matter who is running the function. Like in case of regular function, which object is running the function, this reference will always point to that. But for an arrow function, this will always get inherited from the surrounding lexical scope. Like in this case, surrounding object or surrounding parent is an object. In this case, the surrounding parent is a function. So this reference for the function becomes this reference for these arrow functions. This reference for this object becomes this reference for this arrow function. Now, whatever variables we are accessing with this reference, if they are present in that scope, we'll get the values. If they are not present, we'll get undefined. So we have to be very careful. This is very useful in certain situations. Like I said, in case of nested functions, in case of callbacks, this is very useful. But also we need to exercise some caution when using arrow functions in this kind of situations. As simple as that.
Thanks for watching. If you want to dive deeper into JavaScript with Node.js, don't forget to explore our complete online course. Click the link in the description to get started today. Plus, subscribing to our channel ensures you won't miss out on more valuable content in the future. See you in the class.